In exploratory browsing and berry-picking tasks, such as collecting prior work for a research project, people use hyperlinks to find new information. Typical browsers show linked web pages in separate windows or tabs, making it easy for the user to become disoriented in the maze of information. When many browsers and window tabs are open, it is hard for the user to maintain focus on the task at hand, leading to the problem of digression. We need interfaces that help users maintain context during exploratory browsing. We address this problem with dynamic exploratory browsing interfaces, a new family of interfaces that dynamically acquire web information as metadata summaries and present linked metadata in context. We built an example, the Metadata in Context Expander, or MICE. MICE displays metadata extracted on the fly from standard HTML pages published on popular websites. For an ACM digital library paper, for example, MICE shows rich metadata including the title, abstract, authors, references, and citations. The user can click on a plus button to expand linked new information serendipitously. For example, when she expands a citation for a paper, metadata for that citation is extracted on the fly and presented in context. The expanded citation links to further information that can again be expanded recursively in the same context. The relationship between new and previous information remains visible, helping the user maintain context. MICE works with heterogeneous information types polymorphically. Metadata of different types, including Wikipedia articles, Amazon products, IMDb movies, and many others, can be expanded with type-specific structures and styles in the same context, as serendipitously encountered by the user. A live demo of MICE can be accessed online. Under the hood, MICE is supported by a polymorphic metadata type system. Types integrate metadata, data models, extraction rules, and presentation semantics. Data models specify structures of metadata using fields. When the user expands a linked document, the runtime dynamically selects the appropriate type for the document and extracts metadata of that type using extraction rules. The interface dynamically generates visual elements to present extracted metadata in context, and uses presentation semantics to tailor the visual appearance, such as arranging fields and applying CSS styles to the extracted metadata's type. Type inheritance enable reusing and extending data models and presentation semantics, forming a type hierarchy. The dynamic nature of the extraction and presentation processes enables and scales interfaces like MICE to support serendipitous exploratory browsing with heterogeneous information. The type system, runtime, and the MICE example can be used to transform our browsing and sharing experiences in many other applications.